Okay, so get this. Imagine like predicting how tough a material is, but you don't even touch it. You know what it's made of. Or discovering brand new materials, stuff we've never even thought of, and it's all thanks to algorithms.
It's wild, right? Sounds like we're living in a science fiction movie. But this is actually happening. The power of deep learning is taking us there.
It really is a materials revolution, isn't it? And that's exactly what we're diving into today. We're looking at this super cool research paper, Deep Materials Informatics, Applications of Deep Learning in Material Science.
Yeah, this paper is seriously next level stuff. It shows how deep learning, the same tech that powers self-driving cars, it's not just for those usual AI applications anymore.
So we're not just talking about facial recognition or AI beating everyone at chess anymore.
Exactly. It's going way deeper, literally, into material science.
So we're talking about AI uncovering the secrets of matter itself.
Exactly. And the crazy part is it's doing it in ways we couldn't even imagine before. This paper, it talks about these mind-blowing applications, like, get this, predicting how a material acts just from the stuff it's made of.
Wait, slow down a sec. You're telling me we can now predict how a material will behave, like if it'll be strong or whatever, just from knowing what it's made of. That's I don't know, knowing how strong a building will be just from the list of materials? Without any blueprints, how is that even possible?
That's the power of these algorithms, right? They can go through tons of data and find these hidden patterns, connections that even scientists who've been studying this stuff for years might miss. There's this great example in the paper about predicting a material's properties based on, it's kind of complex, but it's called crystal structures.
Okay, so we've got the ingredients, right? But now we're talking about how those ingredients are arranged. It's like baking, isn't it? I mean, you can put the same stuff in a cake, but depending on how you arrange it, you get a cake or a cookie totally different.
That's a really good analogy.
Mm-hmm.
So the way atoms arrange themselves, their crystal structure, that's what dictates how strong the material is, how flexible it is, all of it.
So deep learning can look at these arrangements, these crystal structures, and know how the material will act in the real world.
That's pretty wild. Yeah, and it gets even wilder. The paper talks about something called multi-scale material behaviors, which sounds super complicated,
Yeah.
but it's actually pretty straightforward.
Okay, I'm all ears. Lay it on me.
Imagine like a tiny, almost invisible crack in something like an airplane wing. Seems small, right?
Yeah.
But over time, that crack, it can spread, and eventually, boom, the whole wing could fail. That's multi-scale material behavior. Tiny changes, big effects.
So it's like a domino effect, but inside the material itself. And deep learning can help us predict those dominoes.
Precisely. Deep learning models are getting really good at connecting the dots between the world of atoms and how they're arranged and how that affects the material as a whole.
My mind is already blown, and we're just getting started here. But before we get too deep into the weeds, can you tell me this? Why should someone who isn't a scientist or engineer care about all this? What's the big deal with this deep learning stuff?
That's a great question. And the answer is, this tech has the potential to change, well, pretty much everything around us. Think about it. Lighter, stronger, more efficient, everything. Planes, cars, buildings.
We're talking even more powerful phones, computers, right?
Exactly. And don't forget about medicine. Imagine materials designed specifically for your body, personalized medicine.
So it's not just about scientists being curious, it's about actually making a better future, right?
Yeah.
A future with materials designed in a way we never could before.
Exactly. And that's why we're talking about it today. We're going to unlock the secrets of this material revolution, one deep learning algorithm at a time.
So deep learning is basically giving us this superpower to see inside materials right down to their atoms. But there's this thing that keeps popping up in the paper, feature engineering free. And I gotta be honest, that sounds kind of, I don't know, techie. Why should I care?
It does sound a little jargony, I'll give you that. But it's actually a huge deal. Think about it this way. Imagine you had to sit down and explain everything about materials to a computer. Like every little rule about how atoms behave, how they bond, all that crazy physics and chemistry stuff. That's kind of what it was like before with traditional modeling. Super tedious.
So it's instead of just mixing flour, sugar, and eggs to bake a cake, you're trying to explain every chemical reaction to the oven.
You got it. Deep learning throws all that out the window. We don't have to spoon feed it the rules anymore. It figures them out on its own just by crunching tons of data.
Wait, seriously? So you're saying just by looking at enough data, Deep learning can understand how materials behave, maybe even better than people who study it for like their whole lives.
That's the crazy part. It can spot these patterns and connections that we might completely miss, even with years of experience. The paper talks about this really cool example. There's this deep learning model called ELMNet. And get this, it can predict how stable a material is, basically, how likely it is to stay together just by knowing what it's made of.
No microscopes, no lab experiments, just like the ingredient list, and it actually works.
It not only works, it actually does a better job than some of the older models that have all that pre-programmed chemical knowledge built in. It's like sometimes the algorithms are better off figuring things out for themselves.
That's kind of wild. But okay, we've talked about analyzing existing materials. What about creating totally new W1s? Can deep learning do that?
Absolutely. Remember those crystal graphs we were talking about? Those like blueprints of how atoms are arranged? Deep learning can use those to do way more than just analyze. We're talking about actually designing materials with specific properties.
So like I could say, hey, I need a material that's super light but also incredibly strong, and deep learning could just like whip up the recipe at the atomic level. That's
That,
straight out of science fiction.
it's becoming science fact. It's like having a digital alchemist.
Mm.
And it's not just theoretical. The paper talks about some really cool examples where deep learning is already designing better microstructures for things like solar panels.
Wait, so more efficient solar panels, more renewable energy. Okay, this is amazing. It seems like deep learning isn't just about understanding materials, it's about using that understanding to build a better future.
100%. And this brings us to another really fascinating aspect, the role of AI in microscopy. The paper talks about this crazy system called MaterialScience. It's a supercomputer that analyzes images from electron microscopes.
So we're talking about those images that show us individual atoms. Don't we already use computers to look at those? What's so special about this Mendel thing?
What's cool about Mendel is that it doesn't just analyze, it learns. Every image it looks at makes it better at spotting these tiny, almost invisible defects in materials, the kind of flaws that could make a material fail.
So it's like having a superpowered intern who never sleeps, never gets tired, and just keeps getting better at finding those needle in a haystack flaws.
Exactly. And because of that, we can start thinking about a future where we have autonomous materials discovery. Imagine AI systems constantly analyzing data, running simulations, leading us to materials we haven't even dreamed of yet.
This is all so cool, like AI designing materials, spotting flaws we can't even see. It's mind-blowing. But let's be real for a sec. It can't be all sunshine and roses, right?
Yeah.
There's got to be some downsides, some challenges we still need to figure out.
Oh, for sure. We're not quite at Star Trek levels of material magic just yet.
Yeah.
One of the biggest hurdles, and we touched on this a bit earlier, is data. These deep learning models, they're hungry for data.
So it's not just about having a ton of data. It's got to be good data too, right? Like accurate and comprehensive, all that. Where are you even getting all this data from?
That's a great question. And honestly, it's one of the biggest bottlenecks right now. We need a mix of experimental data, actually testing stuff in a lab, and simulation data, which is basically running virtual experiments on computers. And both of those, they take a lot of time and resources to generate.
So more data, better data, and the resources to get it all.
Got it. What about the deep learning models themselves? Aren't those super complicated, like really hard to train?
Definitely. Training these models takes serious computing power. We're talking supercomputers running for days, even weeks, just to get these models up to speed. And as the models get more complex, we need even more computing power. It's a constant arms race. Faster computers, better algorithms, more efficient ways to collect and process data. Sounds like there's still a lot to do.
There is. But even with all that, the momentum behind deep learning and material science is incredible. We're seeing these huge breakthroughs happening, and it feels like things are only speeding up.
It really does feel like we're on the verge of something big. Like AI is going to reshape the world, literally from the atoms up. And for everyone listening, this isn't some far-off future. It's happening right now. Deep learning is already changing how we research materials, and that impact is only going to get bigger in the years to come.
Absolutely. The next time you hear about some amazing new technology, a lighter plane, a faster computer, a breakthrough in green energy, remember it might just be because of AI, working behind the scenes, helping us build a future with amazing materials.
What a great point to end on, this deep dive into the world of deep materials informatics. It's been seriously eye-opening. It's clear we're at the start of a materials revolution, and AI is leading the charge.
It's a really exciting time to be working in this field.
And to everyone listening, we hope this deep dive has sparked your curiosity. Keep asking questions, keep learning, because the future of materials is wide open. Until next time, everyone, keep those minds hungry for knowledge.